Hello everyone, so welcome back to the good stuff that we've been doing. Today in this video we're going to try to find Fourier series for f of x equals logarithm of cosine of x. And of course, when we mean logarithm of cosine of x, we mean the logarithm of the absolute value of cosine of x, because this logarithm function does not take in negative values. And also, usually for Fourier series, we define the Fourier series f of x to be a sub o over 2 plus then you have the sum as n runs from 1 up until infinity of, then you have a sub n cos nx. No, usually it's supposed to be cos 2m pi x over L, where L is the period, and then b sub n sine then 2m pi x over L as well. So in this setup here, a sub n is defined, a sub o to begin with is defined to be defined to be 2 over L times the integral. The L is the period times the integral from negative L over 2 to L over 2 of f of x dx. And then a sub n is defined to be 2 over L times the integral from negative L over 2 up until L over 2 of let's say f of x cos nx, f of x, then you have cos 2m pi x over L dx. And then you define b sub n as the same, only that in this case we now have sine 2m pi x over L. But then notice there that we can't use a period of 2 pi because that would be too much repetition for this logarithm function, and we don't accept negative values. So best we use the period of pi, because cosine is still periodic with period pi. So if we use period of pi, then a sub o will become 2 over pi times the integral from negative pi over 2 up until pi over 2 of f of x, which is logarithm of cosine of x dx. So and in this case here now, if we do that, because logarithm of cosine of x is because the interval is symmetric, and logarithm of cosine of x, because cosine of x is an even function, this is going to be even. So this is going to be 4 over pi multiplied by the integral from 0 to pi over 2 of logarithm of cosine of x dx. Now we already know the value of this integral is equals negative pi over 2 log 2 from the theory of definite integrals. So this is going to equal 4 over pi, 4 divided by pi, times negative pi over 2 log 2. So you get negative 2 log 2, negative 2 log 2. So which means that a sub o, which is the constant term, a sub o over 2 is going to be negative log 2. That is the constant term there. Now let's see how we can maybe evaluate b sub n in this our case here. Let me take this okay. Now we don't have to worry about the part that contains the sign, because b sub n here, or let's say a sub n rather. So a sub n here is going to be 2 over pi times the integral from negative pi over 2 to pi over 2 of the logarithm of cosine of x. Then if you put L equals to pi, the pi cancel out and you have 2nx times the cosine of 2nx dx. Now we don't have to worry about the case of b sub n, because b sub n will be 0. Point being that sine is an odd function, so if the integral of a symmetric interval of an odd function will cancel out, it will definitely be 0. So in this case, we'll need to worry about a sub n. Then we will be able to establish this Fourier series. So case here, a sub n is 2 over pi times the integral from negative, we have a symmetric interval here, so we can just write this as 4 over pi times the integral from 0 to pi over 2 here of the logarithm of cosine of x, then cosine of 2nx dx. Okay, so that is that. Now all that remains now to find a sub n is to be able to compute this integral here.